Assalamualaikum, hello students. Now in this video, we are still looking at eigenvalues and eigenvectors. Okay, now we have learned on polynomial method, so that is an analytical method. So in this lecture, we are going to look at numerical method, which is what we call as power method. Now let's recall a bit. For polynomial method, let me just write this down. So for polynomial method, right? The method was we find the eigenvalues. So from there, we calculate the corresponding eigenvectors. Okay? Oops. Eigenvectors. Okay. Now in power method, it's the other way around. All right? We first find our eigenvectors, and from there we determine the eigenvalues. So it's the other way around. Okay, I'm going to go straight into the steps here, for power method. So make a note that this is an iterative method. That means we will have iterations and we will deal with approximations. Okay. Now, let's look at the steps. Let k be the number of iteration. Okay, so the first step is we start with an initial guess. So that would be x0. If the initial guess is not given, let's say we are considering x1, x2 and x3, we always start with 1, 1, 1. Okay, so next, our second step, we calculate ax0. Right? So in this case, our x bar, that would be our eigenvector. Okay, and our lambda here, that would be our eigenvalue. Right. So finding the eigenvalue, as mentioned in the previous video, that would be the largest absolute value. Entry with the largest absolute value. Okay. Third step, rescaling. So I'm just going to write here first, what does rescaling means, So x of k plus 1, note that k is the number of iteration, equals to 1 over lambda k plus 1 times ax k. Now k plus 1 is our current approximation, the current approximation. So xk will be the previous approximation. Alright. Now, in all numerical methods, we must check the convergence. So check for convergence. In this case, we use L infinity. Now L infinity is actually the norm or the length of the size of the matrix. So let me just highlight here. So L infinity is called the L norm, which is the length or measure or size of the matrix. So there's a formula there. So let's look at the formula here. Alright. So L infinity equals to xk plus 1 take away xk. Now this means you have to take away the vectors. Now, let's look at that. You have a double bar there. That doesn't mean the absolute. That is not the modulus sign for absolute value. But the double bar with the infinity sign, that's the size of the matrix. Measure of the size, which equals to the maximum value of xk, entry xk plus 1 take away xk. Alright, so this is the formula that we are going to use to calculate our convergence criteria. Alright, so we have the 4 steps there. So let's straight away look at the example. I've put the steps at the side here, alright, so that it's easy for us to do our calculation. Okay, now question says, use power method to determine the highest eigenvalue. That means we will only find one eigenvalue, the highest eigenvalue, and its corresponding eigenvector, accurate to within epsilon less than 0.005. Alright, so we have learned how to calculate the epsilon just now. Okay, so let's do the first step. Start with an initial guess. If you recall, this is the same question as the one in the video of polynomial method. It's the same question. Yeah. Okay, the first step. Start with an initial guess. So no initial guess is given in the question. So you can start with all entries as 1. So my first step, let me use a different color here. Yeah. Okay. So my step 1. So let us let our initial guess. Okay, since we have a 3 by 3 of matrix A, so we want x1, x2 and x3. So let's say 1, 1, 1. Okay, that's our first step. Step 2, refer to here. We calculate AX0. So step 2, right? We calculate AX0. That will be equals to, our A is 2 minus 1, 0 minus 1, 2. Multiply with x0, 1, 1, 1. Now, if you are still weak in multiplication of matrices, please do some revision on this, yeah? So, multiplying, I'm not going to explain anything here, yeah? We obtain the value 1, 0, 1. So, we obtain a 3 by 1 matrix. Okay. So, this is our second step, yeah? So, from here, from the second step, if you recall what I wrote up here, yeah? From the second step, we want to determine our eigenvalue. Okay. So from this step, we want to find our eigenvalue. And that eigenvalue would be the first one, lambda 1, for example. So what is eigenvalue? Eigenvalue is the entry with the largest absolute value. All right. Let me just take a note here. Yeah? So the eigenvalue is the entry, okay, with largest absolute value. So you have to look at the absolute value first, then only you can decide the entry. Okay, so let's refer to our entries. We have 1, 0, 1. So the entry with the highest, the largest absolute value, that be 1. All right, so the entry is also 1. So therefore, our lambda 1 is equals to 1. That is our second step. Yeah. Step 3, rescaling. Okay, I mentioned the formula here. All right, so rescaling is this formula. Okay, so xk plus 1 equals to 1 over lambda k axk. Okay, let's make that as our step 3. So we want to find x1. Right? So our formula is 1 over lambda k plus 1, which is 1 over lambda 1, times with a previous x, x0. Alright, so that is equals to 1 over lambda 1 is 1. We have already calculated in step 2. Ax0 is also calculated in the previous step, which is this. That's our Ax0. So times with 1, 0, 1. Okay, so multiplying, I obtain 1, 0, 1. Okay, now this is our eigenvector for x1. Alright, our first iteration. But can we accept this as our eigenvector? Yeah, the question says determine the highest eigenvalue. Can we accept this? Now we cannot simply accept, we have to check for our convergence criteria. Step 4. Now the formula for step 4 is L infinity. Alright, that will be equals to x1 take away x0. Alright, the formula for L infinity for x1 and x0 is the maximum value of x1 take away x0. Okay, so what you do here is you have to take away the respective entries. So for example, this is my x1, that is my x0. So entry 1 take away with entry 1. Yeah. So what I have here, that will be equals to, okay, the maximum value, that's the absolute sign. Let's bring that up a bit. Okay, the maximum value of 0 minus 1, 0. Okay, I repeat, where do I get that 0 minus 1, 0? That is just taking away 1, take away 1. That's 0. So 0 take away 1, that's minus 1. And 1 take away 1, that is 0. Okay, so let's continue with that. So let's write that in terms of set here. So that would be the maximum of the absolute value of 0, all entries, and 0. Right? So the absolute value, that would be the maximum of 0, 1, 0. So out of those three, what is the maximum value? That would be equals to 1. So now only you check, is this less than your epsilon value? So in the question, okay, our epsilon value must be less than 0.005. Okay, so obviously this is 1 and it is not less than epsilon. Therefore, we can't accept this as our eigenvector. What does that mean? That means we have to iterate another set. So the next set, we start off with second step. So now we have our x1, yeah? So just bring this down here. Okay. So the next set. Should I just change color? Right. Okay, our next set. We start with step 2. So the step 2, we start with AXK, yeah? So that AX1. Alright. So A is 2 minus 1, 0. Bear with me. 0 minus 1, 2. Okay, we have already calculated x1 from the previous set, which is 1, 0, 1. Okay, now multiplying, our answer is 2 minus 2, 2. So from here, which one has the largest absolute value? So all absolute value is equals to 2. Therefore, let us take that value. Right? So our lambda 2 is the entry with the highest absolute value. We take the one at the top there. Lambda 2 equals to 2. So we go to step 3. So our step 3, that will be approximating x2, the next iteration. So formula is 1 over lambda 2 a x1. So lambda 2 has already been calculated from our second step just now. 1 over 2. AX1 also has been calculated, which is 2 minus 2, 2. So this gives an answer 1 minus 1, 1. So can we stop here? Just as before, we have to check our convergence criteria of L infinity. So the equation is the maximum of the difference between x2 and x1. Alright? So the set is maximum of, so 0, you just take this away, yeah? Minus 1 and 0, alright, which is equals to maximum values of 0, 1 and 0. So out of those three, the maximum value is 1. So check, is this less than 0.005? No, it's not. It's the same answer. It's not less than 0.005. Therefore, you have to continue with another iteration. Okay. change the color back. Alright, so now another set. So we want to approximate x3 now. So step 2, we repeat our next situation with step 2. Now ax2. Alright. So that's our a. Multiplying with x2, that's 1 minus 1, 1. Okay. This gives 3 minus 4, 3. So we need to find our lambda 3 here. So what is our lambda 3? So first we need to check out of those three values, 3 minus 4 and 3, which one has the highest absolute value. So the highest absolute value is that, because it gives value 4. Okay, so what is our lambda 3? Is it minus 4 or is it 4? So recall that our eigenvalue is the entry that has the highest absolute value. So the entry is minus 4. So therefore, our lambda 3 is minus 4. Okay, so this is common mistake that students do. Yeah, so bear in mind it's minus 4, yeah, not 4. Right, so next step, step 3. We want to approximate x3. Okay, so formula, we repeat the same thing. 1 over lambda 3 times ax2. So 1 over minus 4, ax2 is 3, minus 4, 3. Okay, so calculating, that's going to be 0.75, 1 minus 0.75. Okay, so step 4, we check for convergence. For L infinity equals to the maximum of absolute minus 1.75. So absolute of 2 and absolute of minus 1.75. Alright, so the maximum of these three, that will be equals to 2. And this is getting bigger, it seems, and this is not, less than equals to 0.05. So if you ask me at this stage, I will be a bit nervous because it's not converging. Yeah, if you recall, before the answer here, yeah, the size is 1. Now it's getting bigger, but that's all right. Let's do another iteration. Okay, next one. Right, so we start with S2. So now we want to approximate S4, yeah? So we have our AX3. Okay, so please write the calculation there. So our value is minus 2.5, 3.5, minus 2.5. Okay, so now we want our lambda 4. The highest absolute value, that will be 3.5 there. And that entry is positive 3.5. So that will become our lambda 4. So our step 3, we repeat the same thing. So x4 equals to 1 over lambda 4 ax3. Okay, so 1 over 3.5 ax3 is what we've calculated before. Okay, so this gives the answer minus 0.7143, 1 minus 0.7143. Okay, so step 4, check for convergence, our L infinity. Right, so that will be the maximum value of the difference, which is absolute of 0.0357. Okay, absolute of 0 and absolute of 0.0357. Okay, so that is going to be 0.0357. Now the L infinity is getting smaller. Okay, so that's a good sign, but still this is not less than 0.005. Okay, bear with me. Okay, let's do another set. Now is AX4. So I'm just going to go fast here. So AX4 multiplying. Okay, so the value here, we are working in 4 decimal places, right? So minus 2.4286. Okay, so what is going to be our lambda 5 here? So that's the entry with the highest absolute value. So 3.4286. Okay, so next, our step 3, we find x5. So that's 1 over lambda 5 ax4. Alright, so calculating that, that will be equals to minus 0.7083, 0.7083. Now, that looks like a nice number, but could this be our eigenvector? We have to check for our convergence criteria, which is L infinity. Alright, so that will be the maximum value. Yeah, the difference between the two, 0.006. Okay, so our value here is equals to 0.006. That's a bit small, but does that satisfy our epsilon? So epsilon must be 0.005. Still no, we have to add one more. So bear with me. So now we need to find x6, yeah? So a of x5, all right? So our value here, we calculate 4166, okay? Minus 2.4166. Right, so from here, our lambda 6, that is going to be 3.4166. Okay, so our step 3, we find x6. So 1 over lambda 6, ax5. Okay, so now here we obtain minus 0.7073, 1 minus 0.7073. Okay, so our step 4, our convergence criteria, L infinity, that is the maximum value for absolute of 0.001, 0 and 0.001, absolute value, right? So that is equals to 0.001. So does this satisfy the epsilon? Yes, finally. So this is less than 0.05. So once you have checked your convergence criteria, which is L infinity, which one is our eigenvector now? So our eigenvector is the latest, yeah, eigenvector here, there. So therefore, our eigenvector, yeah, so our eigenvector is minus 0.7073, 1 minus 0.7073. So if that is your eigenvector, which is its eigenvalue. Is it lambda 6? Now, don't make the same mistake here. Alright? If you recall, earlier in our lecture, I mentioned here, in polynomial method, we find our eigenvalues, then we calculate our eigenvectors. But in power method, we find our eigenvalues, then we find our eigenvectors, then we calculate our eigenvalues. So in this case, which one is our eigenvalue? Since our eigenvector is at x6, that means our eigenvalue will be calculated later on, would be lambda 7, not lambda 6. So therefore, at this stage, we are not finished yet. Okay, so therefore, to find our eigenvalue, we need to calculate one more iteration, which means ax6. So finding ax6, right? So the value is minus 2.4146, 3.4146 minus 2.4146. So from here, we obtain our eigenvalue, which is lambda 7, which is equals to 3.4146. So therefore, the answer is our eigenvector. Let me just put a note here. So therefore, the eigenvector is minus 0.7073, 1 minus 0.7073 for eigenvalue lambda equals to 3.4146. Hence the question, find the highest eigenvalue. So in your final exam, for example, alright, if this question is given, power method, make sure you show clearly which one is your eigenvector and which one would be your corresponding eigenvalue. Okay?